Yeah.
Well, good morning, everybody. It's 10 a.m. We welcome you to our program today, which we've entitled Give Us 18 Hours and We'll Print You a Home, the Next in Our Mind expansion series. I must admit, I'm still a little surprised to be making that statement, but it's all true. And that's what we're going to take you through today. A couple of quick housekeeping items, as we always do. Please make sure that both your video and audio is muted. There's some glitch in Zoom where occasionally somebody will sneak through and we'll see another face on the screen. If you see yourself on screen, get off there, please. The only three people you should be seeing are the three of us as we speak. There is a chat button at the bottom, as you can see. If you've got a question, please pop it into the chat button. I keep an eye on that through the conversation. If there's a question that we can get a quick answer from, I'll pose it to our panelists, and we'll get a quick response as we speak. And again, the inevitable question I get: yes, we are recording today's program. Later on this afternoon, you will receive a Lux Stream email from us, which has the link to the recording to our YouTube channel where we post these events. So check your spam folder if you don't see that link. So why today's program? Building a house is never for the faint of heart. From the selection of an architect, designer, and contractor to final design, permitting, construction timing, and cost, the process is often fraught with indecision, uncertainty, and surprise, particularly in the Bay Area, where cost is outrageous, and we have all those building codes which know no boundary, and you're all familiar with how tough that can be. That's why we now have a now proven technology, this 3D printing, which provides a fascinating alternative to traditional building methods in terms of sustainability, turnaround time, and overall cost. And with Europe leading the way with the implementation of this new construction technique, we're pretty sure that the US is soon to follow, especially so given the movement now towards the construction of ADUs, particularly in the Bay Area, and the move towards more manageable and smaller homes, particularly with the growth of the retirement community. So we're delighted today to present two experts in the field of 3D printing for the construction industry. One is the world leader in the technology, and the second is the California construction company with, as I term, concrete experience in the business. Our first panelist is Philip Lund-Nielsen, who is co-founder and head of Americas for COBOD, the world leader in 3D construction printing solutions, having 3D printed Europe's first building in 2017. Subsequently, the first 2- and 3-story buildings in Belgium and Germany were made with its technology. And in addition, the first villa in Dubai and the first buildings in Africa have been printed by COBOD's 3D construction printers. The company operates with an open source strategy, partnering with customers, academic institutions, and suppliers around the world, including in the United States, General Electric. Don Ajamian is the principal of Don Ajamian Construction. This California-based company has partnered with Emergent, a company founded in 2019 as a way to help with the car fire rebuilding efforts in Northern California. As a company utilizing 3D concrete printing technology, Emergent's vision is to be a solution to the housing crisis and reinforce the construction industry by reducing the number of homes needed, creating jobs, cutting time costs, and offering rapid build time for clients. Gentlemen, Philip and Don, it's a pleasure to have you with us today. Philip, I'm going to start with you. Let's go to 30,000 feet. Let's just get the overview out of the way quickly. Then I'm going to bring Don in, and we'll get into the nitty gritty. Give me the headlines. What is 3D home printing?
Sure, Alf, and thanks for having me here today. It's always exciting to share and learn about 3D printing with industry professionals. So what is 3D printing? Well, it's a way of automating the construction site. Imagine a big machine, which I believe we'll see in a bit, that deposits layers of concrete on top of each other to create a physical structure from a digital file. So it's a complete disruption of how construction is predominantly done today, which is with skilled labor.
Okay. And COBOD, how long has COBOD been in existence?
Well, as you said before, we 3D printed Europe's first building in 2017, and then now we've expanded and are operating on all six habitable continents.
How many homes have you constructed, give or take, in that period of time, globally?
We have constructed 0 homes because COBOD is not
Right.
a construction company. We're merely a technology provider. However, a lot of our global customers and partners, such as Don here representing Emergent, they have done at least 100 homes and other types of structures besides homes.
Interesting. The last 5 years, let's take that period to today's date, 2024. What's been the growth rate in construction? Is this thing taking off, or is it a gradual creeping build?
It's taking off, and it's taking off rapidly. When we started and when we 3D printed that first building in Europe in 2017, there weren't more than, I would say, 5 or 10 3D printed structures globally, and very few players as well. Whereas today, as mentioned before, our customers alone have printed more than 100 structures on all six habitable continents. So the US, Kenya, Australia, Malaysia, all across Europe, etc., Latin America. And that's just for our business. Now that I would say there are 100 different OEMs and other types of players involved with 3D construction printing.
Is the technology applicable to all parts of the world, or does it make sense for certain countries, certain economic environments, certain climates, etc.?
I would say its use cases and its benefits vary according to region. Some regions where the labor cost is very, very high, then replacing with automation makes a lot of sense. In other areas, our customers focus more on speed. It might be that there's a labor shortage and they cannot get the skilled hands that they need, but the machine automates that, right? So it has less of an issue when it comes to that. So really, it depends on which region you're in, which benefits that our partners see to use the technology.
All right. Just Philip, last question. Coming to the United States only, just want to get an overview just on cost. Let's pick a 3,000 square foot home in a major market, California, Texas, Florida. What are we talking about per square foot? And I understand that you're just constructing the shell. There's the rest of the house, but what does a house come out at? What would a 3,000 square foot home come out at in terms of total construction cost?
A good question, and it's a question I get quite a lot. The answer, again, as you said before, it varies according to the region. We've seen now in many cases that the cost has reached being on par, sometimes a bit cheaper, or sometimes being realistic, it's a bit more. But it's also about not where we are today, but where the industry is headed. Because with the growth rate I mentioned before, and with how steep the learning curve is, there is no doubt in my mind, I might be a bit biased, but there's no doubt in my mind that in a few years, it will be far more competitive to do 3D printing versus conventional methods.
So as with all computer technology, it's a declining cost curve
It moves very, very fast.
as it ramps up.
Yeah.
Don, let me bring you into the conversation. You're using Emergent tech. You've set up this company called Emergent, which is utilizing COBOD technology to construct. How many homes have you constructed, and since what period of time?
Yeah, so in about the last, well, first off, thank you for having us. It is fun to share this information. We started printing about a year and a half ago, and since then we've done 7 homes here in California, 1 down in Burbank, Los Angeles area for Woodbury University, and 6 others up here in Shasta County, in Redding, California, to be specific.
Which is where you're based, I assume.
That's correct. Yep.
But now, before we get into nitty gritty, you've got a video. It's just a 60-second, right? Let's run that so that anybody who has not seen how this actually works, you'll get a quick overview in 60 seconds.
Sounds great. I'll give me a sec to share.
Yeah, I've got your screen shared. Thank you.
Are you seeing the black screen?
I am. I'm seeing the black screen. Thank you.
Oh, okay, so here we go. This is a project where we built 4 homes, 3D printed 4 homes all next to each other for a local housing nonprofit, and it utilized city and state funding to house an at-risk population.
And that's the extruder there, correct?
Correct. Yeah. So we're batching material on site. What you might see in some of these shots is the actual mini batch plant, where we just locally source sand and gravel and cement. We mix it on site and we pump it, and it extrudes layers that are about 1.5 inches tall and 2 inches wide. You can see it leaves a gap in the middle of every wall, and that's where things like plumbing and electric and structure goes. So
Absolutely
that project,
fascinating.
yeah, thank you. That project, we just actually last week received all of our final inspections and certificates of occupancy, and there'll be people living in those very soon.
All right. Let me bring both of you together now. Just, I mean, either or, you answer at will. I've just got my questions here that are important to me. Let's start with cost. Is there any cost differential or cost saving between traditional construction and this construction once it's at handover stage, totally completed? Anybody?
Yeah. So, Philip, if you don't mind, I'll dive in. So I've been a conventional builder for about 34 years now. I'm a general contractor here in California for that amount of time, and obviously most of my career was building homes the conventional way. And I would say this: if you want a square building with 90-degree corners, maybe today, maybe 3D printing is not the choice for you. As Philip said, there could be use cases where it still makes sense if, high cost of labor, real labor shortage. This addresses all of that. But in reality, if all we're doing is 3D printing the walls, the cost of extruding those walls has to compare with the cost of framing the wall, putting drywall on the inside, and putting stucco or siding on the outside. Right now, we can about match that cost. Maybe later on our presentation today, I'll share with you some of the designs that our architects have created, and they are round and curvy and organic, and in my opinion, very beautiful. So my argument would be, imagine trying to build those floor plans using 2x4s and conventional methods. I would argue we could 3D print those very beautiful homes quite a bit less expensively than stick building them. So today, I generally quote people that it's going to cost about the same amount of money. I'm here in Shasta County, but if I were to go down to the San Francisco Bay Area and 3D print a home there, I'm going to use local subcontractors for things like plumbing and electrical and roofing and cabinets and doors and windows. Their costs are what they are. For the portion that we're 3D printing, I can compete with the portion that we're replacing, right? If that makes sense. So we can quote about the same cost per square foot.
What about construction time? Is there any advantage there in terms of days, hours, months?
There is. Again, depending on finish selections, we can save up to about 20% on the time, because when we extrude our walls, once we're done printing, that wall is finished. There's no need for drywall or anything else on the inside. There's no need for stucco or siding on the outside. Now, if somebody chooses to do that, you certainly can, but by eliminating those tasks, we do save quite a bit of time.
So once the home is up, any reduction in HVAC costs?
Philip might have more information. I could just tell you anecdotally from our end that the homes that we printed here in Shasta County, we had to get approved with through the energy code. And in all 4 orientations, we beat the minimum requirement by close to 30%. But Philip may have more, scientific data.
Philip?
Yeah, it's interesting because in the US, the majority of single family homes, I think it's 80 or 90% are stick frame, right? So it's timber. Whereas where I'm from, in Denmark in Europe, you usually build with concrete or it's masonry. I've been based here in Miami, Florida for the past 2 years, and it's masonry as well. Um, the thing about 3D printed walls is that it gives you a benefit in that you often have an exterior printed wall and an interior printed wall. In between those two walls, where my head is currently, that's where you have an air gap. That air gap alone actually helps with insulation, which can drive down your HVAC costs. In addition to that, most of our customers, they of course choose to add insulation where my head is in between those two walls
Right.
to further lower the cost.
Okay.
What he's
The
referring to is the thermal bridging. When you frame with studs, you have that wood stud every 16 inches that transfers heat and cold from outside to inside. We don't have that thermal bridge when we 3D print the walls.
And Don, to that same point, long-term durability. I mean, I've never built a new home. I've lived in a lot of homes in my life, and the upkeep is just drives me insane, depending on what climate, what area I'm in. Is there a long-term durability advantage here?
One of the things that was really attractive to this nonprofit housing group, and the reason they chose to go with 3D printing, is because they have people coming in and out of these units all the time. And so I imagine, like for rentals or for this type of use, like we're describing, having concrete walls, one of their main maintenance expenses is drywall repair when somebody moves out and somebody back in. But again, I think Philip can speak to, in Europe, look at the buildings, that are hundreds of years old, still standing. They're all built out of concrete.
The building I'm sitting in right now, this apartment here, and this building is 20 years old. The apartment I lived in Denmark before moving to Miami is 200 years old, right? In many places around the globe, and especially in Europe, things are built to last, and typically that involves concrete. There is a reason why concrete is the world's second most consumed substance after water. It's used more than all other building materials combined times two. And that's because it's available in most areas. It's very strong building material. It's very resilient. It has long longevity. It's low cost. If you go to Rome and you look at some of those buildings there from the Roman Empire, the Pantheon, that beautiful concrete dome, is 2,000 years old. And we see this as a building material of the future, albeit that, it's not perfect and there are things we can do in order to improve sustainability, but it has a lot of benefits.
Philip, Don and I were talking before you came on, and I raised the issue that given the climatic catastrophes that are taking place, let's take Florida, for instance, where you've got hurricanes coming through with great rapidity nowadays. You've got fires in Napa, etc. It would strike me that this is a more tangible alternative to deal with that sort of catastrophic climatic condition that we're suffering.
I believe I can't speak to the history of Florida, but I believe one of the reasons why there is a lot of concrete block housing down here is because that it is a good alternative. It's a strong material versus, say, doing stick framing, which would probably require more work in order to make it as resilient towards hurricanes. And the season is starting here in just 1 or 2 months.
Right. Don, have you noticed have you had any dealings with insurance companies with this product? Are they, because that's a major issue in certain states, Florida and California being primaries. Is there any reduction in insurance costs, or are you seeing the insurance companies showing some interest in this?
We've seen interest. We've seen no reduction, but certainly everything we've built they've been able to get, mortgages on, they've been able to get insurance on. Our hope is that for areas here in California where folks can only get the California Fair Plan, that maybe we can invoke change there, but it just hasn't happened yet.
All right, it's still too early.
Yeah.
Stay with you, Don, if I could. I'm picking up a question here. Seismic, and obviously California, big seismic issues in terms of seismic refitting. How do we stand up with an earthquake?
Yeah, so one of the ways I describe it is, of course, anything that we built, whether it was the one down in Los Angeles or the ones up here, we had to get them approved through the California Building Code, and we are in a seismic zone too, although our seismic zone is lesser. Don't quote me on what the different zones are, but certainly San Francisco is a higher seismic zone than Shasta County. But it's concrete and rebar. And we get a higher compressive strength out of our 3D printed concrete than most highways or high rises even require. So certainly if a concrete parking structure can exist in a seismic zone, like from a structural standpoint, that's exactly what we're 3D printing. Like our homes so far that we've done, the exterior walls, we 3D print a column in the middle that has rebar in it, and that's what supports the roof. And again, I'm not a structural engineer, but I've been around long enough to understand that, higher seismic zone just means bigger and more rebar going into the design.
Philip, have you had any experience with those 100 homes in the other parts of the world? Have any of those suffered through earthquake at all? And what was the experience if they did?
I don't believe those buildings have undergone earthquake activity, but many of our customers are aware and build accordingly. Emergent, represented by Don, is one of them. We've had one of our customers in Guatemala. They recently finished a small home, which was also built for seismic zones. Our Japanese customers are very much aware too, but we've yet to see one that actually faces one of those not hurricanes, as earthquakes. Yes.
Yeah.
Gotcha. Don, I want to go back to you. You referenced the dealing with the creativity of design, which I think is interesting, particularly if you're doing, I assume, contemporary architecture, if you're a contemporary architect. So you could literally be that flexible in terms of what you construct to the design that you're given.
Well, that's the beauty of it. Middle of last year, we commissioned our architect to just dream. Like, if you didn't have to be straight, square, and plumb, what would you design? And again, I can share my screen if you'd like. I can show you a few of those images. Is now a good time?
Could you do that quickly? Yeah, let's do that quickly.
Yeah, let me get back to sharing here.
And while you do that, because I know you're going to show some stunning buildings now, Don. What we at COBOD say is, don't use technology of the future to replicate solutions of the past. In other words, the only reason why our most buildings and offices right now are squared, right, with no curves, so they don't look fantastic, is because that's what the current construction methods allow for. But with 3D printing, you completely unlock that design freedom, and you can do almost anything within that 3D space, as you will demonstrate, Don.
Yeah.
So what do we got here, Don?
Sorry, I'm trying to pull up some of the others. So this is one that he designed called the Spindrift. See if I can advance through some of these, show you the floor plan. So this is a bit of what I was talking about before. When you talk about cost per square foot comparison, imagine trying to do this one out of wood, whereas the 3D printer, it cares not about curves. In fact, it'll do curves more easily, a curved corner, much more easily than it can do a 90-degree corner, right? And so this was just some of the beauty that, we asked him to create. That we can't replicate with sticks, at least not in any inexpensive fashion, that's for sure.
Okay, that's good. That gives us a good idea, Don.
Yeah.
Gentlemen, so we went through the benefits. Let's get serious here and start talking about the challenges. How is the consumer responding? What are consumers saying to you about this? Is it unknown at this point?
I would say it's if I start, Don, there's a lot of awareness and especially from the media and our customers' homes have been featured on all prominent TV stations. So ABC News, CNN, BBC, etc., and all the big online agencies, etc., have showcased this. When we were when we have a regular year, we receive around 10,000 leads on our website alone. We don't do active marketing that hard, right? So there's so much interest about this technology, and I think a lot of that is driven by just how it looks. It looks quite futuristic. It looks quite fantastic.
But
Yeah,
it would be fair to say that that generally speaking, within the contractor, architect, designer, and consumer communities, it's still a little Buck Rogers, yes?
Yeah, well,
Don,
I wouldn't expect like any like if I asked a random person on the street, have you
Yeah.
seen a 3D printed home or do you know what it is? They probably wouldn't, but I think we're getting there.
Don, anything to add to that?
well, it's easy to sell on the design because you can design such beautiful things. Some of the feedback we're getting from the folks that are actually now living in some of the homes we've done are the things that they never thought of. When they shut the door, they say how quiet it is in the house, like how, it just outside noise. We built one of them on a major road through town, and they talk about how quiet it is. They talk about it just being cool in there. Even on the warmest days, it's cool in there. They say things like it just feels really solid, all the things that they wouldn't have necessarily thought of by looking at the beautiful renderings and plans.
Stay with you, Don. Permitting issues. So if I take the plans to Marin County, which is like dealing with Satan, from a permitting point of view, what's going to happen?
So we did it first here in Reading, and thankfully I had the city manager behind us on this, because typically when I go to a building department, the first thing they ask is, show me where else it's been done in California, and we'll see how they approved it, and then we'll look at it. But since I had that backing, we ultimately got it approved here, and then we got it pre-approved in 3 other jurisdictions up here in Northern California. So that would be the first thing. If I was going to build something in Marin County, I would show them how we got it approved here first, and then walk through the specifics of the design that we're building down there. Much of what we would present to them, it's within the current building code. Now, costs will really drop when we don't have to overbuild, right? We're 3D printing with concrete that we get 7, 8, 9,000 PSI out of the concrete, which is very strong. Like typical construction is 2,000 to 2,500. And when we can actually use our 3D printed walls as the real structure, our costs will really come down. Right now, we're mostly 3D printing form work for what is the structure inside, just so we can get through current California building codes.
When you do go in for permitting approval, where do you tend to get the most pain? Where do they tend to give you the most difficulty?
It's generally on the structural side. Generally the structural design. They want to make sure they wrap their heads around that. We have to prove some things out. There are some aspects of this that let's face it, I mean, concrete's been around forever and they can run the numbers, but one of the things that we have to walk them through is the bonding between the layers, how strong is that bond, right? I mean, it's easy to understand if we set up forms and we fill it full of concrete, it's this monolithic, slab. But when we're layering it, how good is the bond between layers? And so we have to prove some of those kinds of things out and walk them through. So most of the pushback is with the delivery system of the material and how it will perform in the long run. And we've got testing and results that we can prove that out.
Incidentally, how strong is the bond between the layers?
We had to prove it out. And again, rather than quote numbers, I could just tell you anecdotally, we as we were 3D printing our first sets of homes, we actually simultaneously printed a small test section right in the middle of the living room floor. And it ended up, 12 layers tall. And then we let it cure and we saw cut sections out. And when you hold that 2 foot by 2 foot section up, clearly you could see the layers on each side. But where you saw cut it and you look at that saw cut end, literally you can't find the start of one layer and the end of the next. It looks like a monolithic pour.
I can show here. We have a sample here of just a 3D printed wall sample, and you can make out the lines right here, barely actually. It's very smooth, by the way. But when you look here, cut from the side, as Don said, it's monolithic. You can't really make out the individual layers.
Gotcha.
Yeah.
And that's what they want to see.
And
if I can add
them. Oh, I'm sorry.
No, I was just adding to your, you could say, sort of frustrations in sometimes getting this permitted. Alf, I think it's important to say that 3D printing, like so many other technologies, we see that the technology is 2 or 3 years ahead of regulation. But as the adoption of this increases, as more buildings get done with 3D printing, it'll come along. They'll get more comfortable with it.
Right.
The codes and standards will be developed, and then it'll become just another construction method.
Gotcha. I'm going to stay with you, Philip, if I can. In terms of contractors, I'm assuming that this is not a broadly accepted technology and protocol right now within the contractor community. There aren't a lot of contractors doing what Don's doing. Is that fair to say?
Yeah, that's fair to say. I would say if we look at all 3D printed buildings in the world, we're probably talking 250, 300 on a global scale. And I believe in the US alone, there's built more than a million, around a million a year, something like that. So it's a very, very, very tiny fraction of the whole market.
Gotcha. I got a question here, Don, if you answer. Can you use GFRC? I have no idea what that is, to avoid steel rebar.
I'll be honest, I'm not sure what GFRC stands for either. Maybe whoever asked can clarify that.
Joe, if you can type in what GFRC stands for, we'll pick that question up and put it back to Don at a later point. Don, when things go wrong in the construction process, what goes wrong?
Oh, what goes wrong during the 3D print process?
Yes. Don't tell me it doesn't go wrong, because we know it does.
So
don't break my heart, Don.
No, I won't say anything that you haven't heard from me many times, Philip. So we printed the same floor plan 6 times here in the city of Reading, which was really nice because we were able to measure our challenges and our improvements all along the way. And when we started printing the first one, it was 100 degrees, out. And by the time we were doing, number 3 or 4 or 5, we were in the 50s and 60s. So one of the major challenges was adjusting layer times and mix design based on the temperature. And then you might get your mix design dialed in the morning when it's 60 degrees out, but then when it's 80 degrees, 4 hours later, you're having to modify. And the layer time is very important because you need enough time between layers so that one layer can support the next, but not too much time between layers where you don't get the bond that's required. We talked about earlier. And so that's a big challenge, certainly. So climate, weather, rain, things like that. But then also, I would say one of the bigger challenges is overcoming the unknowns of the other trades. People like the plumbers, the electricians, we have them working alongside the print crew, and they're doing things as they go. Once they've done 1 or 2, they realize, oh my gosh, this is great. It's pretty straightforward. But going in, and I've been a contractor for a long time, going in, they have a lot of questions, a lot of fear, a lot of unknowns, and all those add up to just a lot more money. They want to charge more. And then pretty soon they realize that they don't have as much to worry about. So education is a big one to overcome that we're still working on.
By the way, I'm getting a lot of questions about windows and door detail. We're getting to that, folks. It's on the list. That GFRC was glass fiber reinforced concrete. Does that make? So
Yes.
the answer is
Yes. So right now we're only using rebar in it. Well, I'd say our LA project was different. The ones we did here in Reading, we're only using rebar in a vertical orientation as our columns that support the roof structure. And so we would still need those, right? We are using fiberglass. We're using fibers in our mix design when we extrude, and that does help prevent cracking. It helps prevent, it does do its benefits, but I don't see it replacing our rebar 100%, at least not today in the current.
Let's get into this question that's on everybody's mind. The sort of the design elements, color, flooring, window treatments, roofing, electrical, plumbing. How do you incorporate that? Philip, do you want to kick off, and then Don, you get into the granular?
Sure thing. For all of these various, you can say, side activities, we've had to come up with ways of solving it. I can show you a few photos here. I think it makes more sense than me explaining it. Starting with windows. So how do you print windows? Because obviously you cannot print into midair. So the way you do it is, if everybody sees my screen here, is that
We've got
perfect. As you get to an opening, then someone will place say a steel lintel, so just a flat bar that you then print on top of. So if we go to the next page here, you can actually see how that looks in practice with the lintels installed. And you can even see that the print head to the left is approaching the lintel and will then print over it, as you see here. And that's another thing I wanted to show. As you get higher up in the air, it becomes harder to see what you're printing. So we have cameras installed on both sides of the print head, so the operator can actually watch this or looking at this as they print.
Fascinating. So where does the plumbing go, and where do the wires go? Don?
Yeah, when we 3D print any wall, we always leave a gap in the middle, and the gap that's designed into it is based upon what we know will have to go in there. So if we know there's going to be plumbing in there, we'll leave a bigger gap. And some of that gets installed as we're going. Some of it can just happen after the fact. But with the electric, for example, we just have a single electrician on site. When we get up to the outlet height, he simply installs his boxes in the still pliable material. So now the back of his electrical box is within that void cavity in the back, and he can run his conduit and cabling afterwards.
I can show an example here.
Please.
Yeah, so to the right, you see electrical sockets that are where the electricians will come in after and install. So these are just styrofoam cups. So you place these styrofoam cups, and as with the lintel you saw before, the printer will print on top of it. Afterwards, you just poke them out, and now you can install the electrical socket. And in between the exterior and the interior wall, that's where you can run your conduit. That's where you can run your insulation, etc., plumbing.
Question though, I mean, my experience has been that plumbers and electricians will, or just the design will be subject to change orders, etc. So I want to move the electrical outlets. I want to move the box. What do I do then? Do I have to cut through the concrete after it's already cured? Don?
Yeah, that is what you would have to do in that case. And I can tell you as a contractor, I kind of like that that maybe that's taken off the table, right? And we could have a little deeper conversation with our customer ahead of time to say, hey, look, anything's possible, but let's try to get it right to begin with. I can't tell you how many times in my stick frame world, that, somebody walks into now a framed up house and they walk into a bedroom and they wish it was a foot bigger and they'll ask me to move a wall a foot, right? It's just not quite that easy in the 3D printing world. So anything can be done, but it would add some cost, certainly.
And Don, staying with that same point I had here, what if I want to remodel the house after I've lived in it for a couple of years? Can I knock down a wall? Can I extend a room? Can I add on some square footage? What happens there?
You absolutely can. Again, it's a concrete home and it will be subject to, structural review, right? I mean, if there's a structural wall you're going to take out, then your engineer has to design for it not being there anymore. But again, anything's possible. I mean, I can cut through drywall or I can cut through concrete if I have the right tool, and then you can add on, certainly.
I've got a couple of nitty gritties here. First question is the install equipment rented for the install or does the contractor purchase it?
Oh, the 3D printing equipment?
Yes.
So we
do both.
That.
Yeah.
Oh, go ahead, Philip.
Go ahead.
Yeah,
Philip.
we both sell direct as in Don's example, and some of our distributors have actually started leasing out the equipment as well. And I think we're going to see this moving in the same direction as any other heavy construction equipment, where a lot of it is being leased, right? If you're doing a new construction project, you probably wouldn't go and buy your own, say, telehandler, right? You'd probably lease it for that specific project. So I think as the industry mature, we're going to see the same for 3D printing.
Philip, can you do different colors? Can you do a pink house if you wanted one?
Yeah, yes. You can add pigment to the concrete mix itself. Here's an example from one of our customers in Angola, Africa. They wanted sort of more earthy colors. So I believe for this one, we were connected with Cemex, one of our investors, and you can see those some samples there to the right. But you could also mix in like blue or pink or green pigments. Here's an example in Tulum, Mexico, not 3D printed, but it has like a blue hue to it if you get up close, which look quite nice. The pigment though can add some cost to the project, so maybe like 10 to 20% extra per cubic yard.
Don, I've got the frame built. I'm in the kitchen, and I want to stick the cabinets, join the cabinets to the wall. How the hell do I do that?
Yeah, so there's any number of concrete anchors you drill and screw in. There's a brand called Tapcon that certainly you can use. Just like hanging a TV or anything else on the wall, the concrete is very strong. But you pre-drill a hole and you run a concrete screw. That's simply how we do it.
That's simple.
Yeah.
Stay with you, Don. Just I want to get the sort of the timeline. The exterior walls are constructed. What tends to be the schedule after that? When does the plumber come in? When does the electrician come in? When does the roof go on? When does the AC go in? What's the cycle?
Yeah, so while we're printing, some of the plumbing and electric rough-in is being done simultaneously. So by the time we are done with the 3D print part and we're taking the machine down, structure within the walls is being completed, and that takes a few days. Once that's done, roof trusses can go on, and then electricians finish, and then you're finishing a home kind of conventionally at that point.
Right. The timing issue. I want to get homeowner. A quick question: what's the cure time on a completed printed home, Don?
So we're able to actually put load on it as far as roof, beams and trusses within a week after printing. We're fine with that. The concrete technically doesn't get up to full strength until for 28 days. But we have such high compressive strength that we hit our numbers usually long before that.
And what happens if it rains or you get a major storm with a lot of water during the time that it's curing?
That's wonderful. We want like this. If we could slow down the curing process, it helps avoid the little micro cracking. We like to keep the layers wet. So a little bit of mist in the air is perfect for us. As long as it's not a direct heavy downpour during active printing, we actually would kind of like that. If it would rain every night and be clear every day, that would be wonderful.
We're even
I mean,
developing a misting head for the print head that will automatically just mist the print as you go, to cure that concrete better with to avoid these micro cracks.
all right. We're at the 15-minute mark here, and I've got more stuff, and we're getting a lot of questions coming through. Here's one. How do construction tolerances compare to traditional stick building? Don?
So if you can imagine it, the computer is absolutely, positively 100% perfect. That becomes the challenge when, the plumber laid out his, toilet drain back when you were forming up, and he didn't quite get it right. And that becomes a challenge. I can't tell you, in conventional construction, I can't tell you how many times the framer had to move his wall over a little bit just because the plumbing wasn't in the right spot. So that is a challenge. And sometimes we've had to modify our print file when we show up and we realize, oh, they were a little off here and there. The other variable is that the computer calculates it like exactly precise. However, our 2-inch wide layer doesn't always land at exactly precisely 2 inches. And so we have to watch rough openings for doors and windows closely, just for that reason. And again, these are all things we're working through today.
How much surrounding space do you need for the equipment, the extruding equipment? Do you need X number of feet on either side of the walls?
You want to take that one, Philip?
Yeah,
Philip?
sure. Yeah, you do. So we typically distinguish between the printable area, where that is the 3D space that you can actually get a physical structure made in, and then the installation area, which includes the machine itself. If you want to do let's say a house that's 2,000 square feet, for the installation area, I would say you add at least 10 to 15% extra on the sides for where you install the machine itself.
Gotcha. That's what I wanted to get at. Let's go to the homeowner response. Philip, start with you, and then Don, the same question. Generally speaking, once it's been up and they've lived in it for a year or 18 months or 2 years, are they unhappy? Are they happy? Did they like it? What do they and if you're prioritizing what they like about it most, what's the one thing they like about it most, and what's the one thing they hate about it most? Philip, start with you.
From what we hear, it's very much back to what you said before, Don, but it's really that more intangible part of being a resident, right? So the quality of the home, right? That it feels very sturdy, right? That the insulation is good, so it's not heated too much. That it lowers the cost of living. That the noise that is not vibrating off the walls, or it's a very noisy environment because you can hear the street. All those factors are what they like the most. If there's one factor they dislike, there's a lot of people that come up and will take photos of the of the house, and because they're very fascinated by how these structures look. Even for the construction process itself, Don can speak to this. You will have people that will drive hours away from the construction site. They will go there just to watch a construction site going on, like it's a Taylor Swift concert, right? I don't think in the history of construction that has really been a big thing, that people will go there like tourists.
Interesting. Don, you want to add anything to that?
No, I think I said it before. It's those intangibles, the quiet, the cool, the solid. Those are the things we've been hearing. Having said that, I don't have dozens of people that have lived in these homes for years. I've got
I got it. It's still new.
Yeah, it's very
new. I want to talk about the early client adopters. I made a note to myself. I would suspect that people who drive Teslas are probably a great audience for this. It's somebody who wants to be the first with technology. But is there a definable trend, Philip, that you're seeing either globally or in the United States in terms of who tends to want to get into this in terms of the consumer? Is it millennials? Is it Gen X? Is it Tesla owners?
it varies quite a lot according to the use case. Our customers are not just printing homes, they're also printing data centers, they're printing water tanks, they're printing wind turbines, etc. So the range of use cases is quite wide, along with the geographical footprint. If we're looking just at homes, it's also very wide from those that want affordable homes because you automate the construction site in order to make it cheaper, to make it faster, to the more luxurious homes where they want spectacular organic designs, so the house stands out from the crowd, from the neighbors. And the good thing about 3D printing is that it caters to both. It doesn't care if it's printing a circle or if it's printing a rectangle. The cost is exactly the same.
It would strike me, though, that the early adopters here are going to be sort of government money, not for profit construction. It's going to take a while for the for-profit sector to drink the Kool-Aid. Yes,
That's true. Yeah, I mean, Emergent was founded because of the car fire. So disaster recovery is a big part of what we're all about. And
that's
it's a
your
great
entry
solution.
level.
I'm sorry.
That's your entry level,
That
as you
yeah,
will.
yeah. Well, and you know, for somebody who lost their home in a fire or a hurricane, they kind of like the idea of a concrete home, right? It gives them a
Yeah.
lot of peace of mind. But it's also another great use is like transitional housing. We talked about it earlier. You know, if it's a home where people are going to come and go, the maintenance of this home is a lot easier. But as we hone our craft in the government, you know, maybe sponsored projects that we are doing, it won't be long before we're, you know, very competitive on the retail construction side as well.
Don, what response are you getting from architects and interior designers? Do they sort of roll their eyes? I don't see architects knowing what this is all about.
When they wrap their head around it, the architects just love it. They, you know, some of them, they don't have the software to create what can now be done, right? I keep repeating, you know, we're no longer bound by straight, square, and plumb. Please think way outside the box, like literally.
And that excites them.
And it excites them. Yeah.
All right. Did you see that question, Philip, that just came up there on?
I'm already on it. I'm finding a video, one of Don's projects actually. So the first 3D printed permitted house in California, and this video was, I think it was shortly after the inauguration of the home. Let me just see here if this is the one. Yep, I think that's it. Give me just 1 sec to share the screen. Yeah,
Is this just a couple of okay?
Yeah,
Go ahead.
it's here, and then hopefully this is the inauguration of one of Don's homes. You can see the exterior with like a nice stock going there, and then here's a video.
Now, is that sheetrock on the interior, or is that?
No, it's just a skim coat of concrete, actually.
Gotcha. Okay.
A sheetrock on the ceiling. That's the only place.
Got it.
So,
Fascinating. Gentlemen, we've got 5 minutes here. I got a couple of quick questions, if I may. This one, so too quickly. Philip, to you, do you any numbers, any experience on home appreciation over the long term? Do we think these homes are going to increase exponentially in appraised value versus a traditional stick home? And if so, why?
at least I think they're built to last, right? In many cases here in the US, but also elsewhere, you might build homes that are intended to last just a generation, 30 or 40 years. You knock them down, you build something new. Whereas concrete buildings generally have a longer lifespan. Maybe they'll last you 100 or even more than that, 100 years. And so I think that's what we're going to see. I also think once the stories get out about all these intangible benefits we've discussed before, then that could help drive up prices too.
And to that point, it makes sense for certain parts of the country for this type of. I mean, I'm thinking this is tailor-made for Florida, where you've got exceptional, heat, and you've got those hurricanes. It's got to be great for Texas. It's got to be great for California with earthquakes and fires. So there's certain parts of the country where this would make more sense. Yes, Philip.
Yeah, I mean, anywhere in the world or anywhere in the U.S. Where there is issues with construction, this could have a space, right? Whether it's might be cost in one area, lack of skilled labor in another area, a lack of interesting designs in the third area, then 3D printing can address it. But being realistic here, I don't think 3D printing is the end all be all. Construction is the world's largest sector at least $12 trillion globally. It has numerous issues, and it'll take numerous solutions besides 3D printing to solve them all.
Don, to both you and to Philip, have you had any experience with mortgage lenders, banks, financial institutions in terms of this technology? Are they saying no? Are they saying let's wait and see? What are you hearing? Even though it's anecdotal.
We've actually had direct conversations with them, and there's been lending. It's a foundation in the ground. It's concrete material. The only thing different is the way we're delivering the concrete. So the mortgage companies have had zero issue. The appraisers have had zero issue with the 3D printed homes.
And Don, staying with
just short note here. Freddie Mac last year updated their appraisal report, stating directly that 3D printing should be considered on par with conventional construction methods when it comes to loans and insurance. If you have a big player like Freddie Mac saying that, then it's starting to get serious.
Don, a quick question. The product that you extrude, does that vary? Does the formula stay the same all the way in every construction project, or do you vary the extruded product based on the need?
We vary it slightly, again, depending on the climate, depending on the time of year and that type of thing. Also, with the solution that COBOD created for us, along with the partner CEMEX, we use locally sourced materials. So when we go print, in other parts of the country or state or world, we will buy sand, gravel, cement locally, and it's different wherever we go. So we will alter a formula based upon the type of material that's available locally.
Gotcha. And again, it's a basic mix, right? I mean, it's concrete and water and sand and that's it.
And then a few other additives like the fibers, and then there's a product that CEMEX created again with COBOD that makes that standard concrete 3D printable. It gives it the consistency of toothpaste, let's call it, instead of being quite so runny, it allows it to layer up and stack.
Final question, Phil, I'm going to start with you, then I go to you, Don. Take me through 2030. Where are we now? 6 years out. That's a good time frame. What do you think is going to happen in the next 6 years?
It's always hard to predict the future. If you'd asked me when we printed Europe's first building in 2017, if I'd be in Miami and over here having this webinar, I don't think I would have believed you. So if we look 6 years forward, I think one, the technology is going to mature. So it's going to be more precise. It's going to become faster. It's going to become cheaper, like other emerging technologies, such as where the cell phone was maybe 20 years ago. Number two, I think we're going to see projects get bigger, not just in volume, but also in the size of each individual home. And then number three, I think we're going to see an upskilling of the labor workforce. So we're going to see architects, engineers, construction workers start to integrate 3D printing more in their processes, hopefully also raising their salaries while we're at it.
Don, do you want to add to that?
Design is what's going to drive this industry from my perspective. As the general public sees what is possible, their demand is going to push this. Built architects are going to start designing based on what can be done, and the only way you can produce it in any sort of economic fashion will be with 3D printing. I think it's going to be the architects and the general public's real desire for these organic, beautiful shapes, again, getting away from the straight squaring plumb, that's really going to drive this industry.
Interesting. Don, will you do me a favor to the extent that you want to be contacted? I know there's going to be a lot of people want to talk to you. If you don't mind putting a phone number or an email address or a website or something, type it in. That would be wonderful.
Certainly.
Philip, I want to thank you very much for taking my call and for bringing Don into the conversation. This has been a fantastic program today. I've learned so much, and I hope our friends out there have as well. And Don, while you're typing, thank you. It was great to have somebody who's got the scar tissue, who's gone through the good and the bad times. With that, ladies and gentlemen, we're at the top of the hour. We are adjourned. I remind you again, we have recorded today's program. We'll send you out a LuxStream link this afternoon, and you'll be able to access this program on our YouTube channel if there's an element that you want to go back and look at again. So with that, Philip, thank you. Don, thank you. It's been a delight. And ladies and gentlemen, we are adjourned for the day. Let's go print some houses.
Thank you, Alf.
Thank you, Alf.
everybody.
All right. Take
Take
care.
care. Bye.
Bye.